Hello everyone, hello Zimbabwe, hello Africa, hello the entire world. So today I've come on something different. You remember today, every day we are fixing things, various kind of devices. But today I decided to do a challenge. I think we can do this together. If you are in electronics and you love playing with a lot of devices, fixing, trying to detect faults and fix them, probably we are friends for life. So what we want to do today, we want to build a variable linear power supply. You know, lab power supply. Few days ago I did a video where I was explaining how you can use a variable adjustable power supply, and today we want to build one. This might be useful, especially in Africa, where it's even hard to buy something online because the shipping cost and the duty will kill you, especially in my country. You might find out if you want to buy something maybe for $5, the shipping cost will be like 10 times the buying price, which is crazy. So let's see if we can build a variable power supply. No research. I didn't do any research, but I was just collecting random components and we want to try to build something from scratch. What I did, this is the cover from the ATX switching power supply for desktop power supply, you know. So what I've done, I took out everything from inside, and what is left is the fan, and here we have the AC in connector here and the switch. That's what is left. So I want to start to build a adjustable power supply. So where can you start? Actually, we have to know what do we need here. Let's see what we need exactly here, because we want to build this thing from scratch. That's what we want to do. I was just taking random things which I think they are necessary for this kind of video. So we have to play with electronics tonight. It's around the 7 p.m. So what else do we need? We need more soldering wire, and we need after we have built, if we are going to succeed, we'll try to write the schematics so that everyone will get to understand what we were trying to do here. So what we want first, we need a transformer, because we want to build a linear one. So I'll use this transformer. It's outputting 23 volts. What about this one? 12 volts output. Okay. So what we'll do, we'll try to build these things in A, and we'll put everything in the box, and we'll assess our performance after. So we need a transistor. a transistor. We have some transistors here. Let's check. This is not a good transistor. What about this one? This looks good. The C5296. 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 C5296 transistor. That's NPN transistor. So we need this transistor and a heat sink. Let's put the transistor on heat sink. So the important aspect here is to do this thing together, so that if we succeed, you will do yours at home. Even myself. So we have our transistor here. It's a C5296. That's NPN transistor, meaning this is our base, collector and emitter. So what we need, we now have our transistor, a solder, put solder here. After the transistor, what do we need? We need a variable resistor. You know the switching variable resistor. Where can I get one? Yeah, I found one here. Let's try to do this from scratch. Now our variable resistor seems to be fine. So that's our variable resistor, or what other name is this component? Adjustable resistor, variable resistor, or what do you call it? Potentiometer. Potentiometer. Let's see. Potentiometer. Yeah, that's the thing. It's just an adjustable voltage divider, nothing special. Nothing special about this component. So what we need to do, we need to connect our thing to a NPN. We need to connect our thing to a NPN. We shall connect the collector and base only. We will eliminate the emitter. So I'll explain why you should build something like that, especially in a poor country like Zimbabwe. I will explain why you should build a variable switching power supply or variable linear power supply. We've connected our switch, our variable switch or voltage divider to our NPN transistor. Now we need to connect the input wires. We need 2 wires for the input. So wires for the input. Yeah, this might be a long video because there's no research here. There's no research or anything. We are starting everything from scratch. So don't forget, don't worry about other components. Let's concentrate on what I'm doing here. We need the input wires. We need the input wires. Plus in minus plus and minus. Our minus, we are connecting on the 3rd pin of our variable resistor, voltage divider, whatever you call it, and so that's what I was trying to explain on that video, that the best way to learn electronics is to do it by yourself. No one is going to teach you. If you are busy looking for like a college degree or a university or like a program to undertake, maybe you are just wasting your time. Maybe you are just wasting your time. That is not going to help you in any ways. Now these 2 wires, they are going to the input. So what we have done here, we just connected our voltage divider to the NPN transistor, and remember We only use base and collector. So these wires, they are going to the input. Fine. The next step, we need like what do we need? We need to sort out the output thing. What is this? An idea? You know, you see these things? What are their code? These ones. I was taking these things from inverters. You know, 1000 watts, 1.5 watts, 2000 watts inverter for the display. They are called, what they are called, I'm still thinking about the name. They are called, what they are called, these things. So adjustable voltmeter. 1 second. Adjustable voltmeter module. Yeah, adjustable voltmeter module. These ones. These are adjustable voltmeter module. In my case, they are working from 5 volts to 30 volts. So we need to connect this adjustable thing in the ground. The black wire is always on the minus, on the negative. Let's try to connect, because this thing is meant to give us readings of the output voltage from the power supply. That's the use of this adjustable voltmeter module. So red wire here on the collector of this transistor, and the yellow one should be collected to the emitter. Let's connect the yellow one. Yellow should be connected to the emitter. And remember, yeah, I missed one thing. We need like a resistor. We need a resistor. We need a resistor. Because this is the output. We are dealing with the variable ohms. Let me see this resistor. How many ohms? ohms. Why I can't get value of this resistor? Why? Because you need a resistor between 10 to 15 kilo ohms. Why I can't get values of these resistors? Let me restart my multimeter. Zero 0.98. Sorry, 98 ohms. No, not this one. No value. It's now hard to get a resistor. 306 kilo ohms. This is too much. 321. What about this one? $10 kilo ohms. This should be fine. This should be fine. So what I will do, I'll connect this resistor in serial with the output voltage, set on the red wire. Hopefully you are seeing what I'm doing here. Well, let me clear out other things so that you won't get confused. Let me put other things aside so that we won't have too many things scattered on the table. Because we have to see, guys, what's going on here. Our resistor, 10 kilo ohms resistor, it's not a must to use like a 10 kilo ohms resistor, but it depends with the amount of voltage that you are dealing with. You can put a higher or a lower resistor. So our resistor straight here. That's our resistor. So what is left now? I think before connecting now, the part which is left is to connect the transformer and other things, but we need to we don't want to go too far without testing. So let's supply the voltage. The current is too much. I think we need something like 2 amps or 1 point something. Our thing is working. You see, we have something here. Let me get rid of reflection. What can I use? We can use something to get rid of the reflection here. Check here. Let's try to adjust. It's working, you see? Ten volts. Why you are getting only 10 volts? That's not good, because that's what we will apply. Okay, let's raise the voltage to 30 volts, 20. You see, check here. So it seems as if we are in the right direction. What do you think? 21 volts. Fine. So we are in the right direction. We are in the right direction. That's good to know that we are in the right direction. So now I think that's the moment when you need this thing. It's now the high moment to start putting the transformer and other things. Transformer and other things. That's the transformer. And we need something here. Let's cut here, because from my own understanding, there's no circuit without a fuse. So I think we need to put a fuse here. Where to get a fuse? We do have one here. So at least we are going somewhere. At least we are going somewhere. Let's connect the fuse. We're now connecting the transformer to the input, because our output is fine. Our output seems to be okay. Is this a good fuse? Diode. Yeah, our fuse is good, because a fuse is very important to protect the circuit in case of any short. That's why we must always have a fuse on the input. Now, what I shall use, this the main transformer for this panel, and for the other one, what are we going to use? Because we do have fan, a fan is connected to 12 volts, so I'll use this smaller transformer. So let's take our transformer. Let's take our transformer, our big transformer, in position. How we can do this? Or let's wait. We need to solder the wires first. I think that's a good idea. We need to solder these wires first. The small transformer like this, a bigger one. We want to see if at the end we are going to have a working adjustable power supply or not. Because the whole idea is to do it by your own. I'm tired of buying fake things, you know. So it's a good moment to do it by myself. I think we can do it. I have that feeling that we can do it. We can do it. I'm just connecting the input of the linear transformer, because you remember when I was explaining my power supply which I'm using is a switching one. So basically a switching power supply is good, but it's got its own disadvantage. You don't have room for mistakes there. No room for mistakes. If anything got wrong, that's the end of the story. But on a linear one like this one, if anything went wrong here, we can still be in a position to fix. So let's play with the hot glue to stick everything here. like this. And the other one, how do I put the other one? Like this. Yeah, just be patient. The problem, what you are doing here is real, so I can't skip any stage. You have to do it, because at the end, you must have a working device. Okay, now our transformer is now in place, our fuse is good. What else do we need here? We have outputs, this one's for the 12 volts. Now, what do we want? We need a bridge rectifier. If I can get one. Bridge rectifier. Bridge rectifier here. What else? We need a capacitor. 50 volts capacitor, just to filter the voltage. Hopefully, I'm not doing something complicated here. Hopefully. So plus minus AC. We need another heat sink for the rectifier, maybe, but we are dealing with low voltage and this size of rectifier. I don't think we need any heat sink here. I don't think so. I'm running out of wires. Let me look for some wires. Yeah, I found some wires, so let's continue with our repair. But before we continue, I think it's good to test if this transformer, they are keeping any kind of output. So here we can plug the AC AC and turn on the switch. Yeah, I can hear some sound. We do have two transformers. So the first one, (15 volts), and the second one, input 24 DC after being rectified. (21 volts) DC, which is fine. So we are good. Let's unplug here. Let's unplug here. Let's try to connect this, the capacitor. Where is my capacitor? Yeah, the plus of the rectifier is here. Yeah. So yeah, let's do it. I'm now connecting the capacitor because that's the switch, that's the sequence of a linear power supply. That's the sequence. So our capacitor that's our capacitor, 50 volts, 680 micro. Now we need the negative wire. Too many wires. Too many wires. That's the minus of the bridge rectifier, which is going straight to the negative side of the electrolyte capacitor. Now we have too many time here. Too many time. The time is plenty. And besides that, there's no hurry in Africa. We are in Africa, there's no hurry. The workflow these days is very low. So I found this as a good moment to be like serious on the beginner lessons. Start building things. So connecting negative terminal, good. So our rectifier is now in place and we have connected our capacitor, and what we need You remember what we did here? Our first thing, potentiometer, this one, the variable or adjustable resistor, our NPN transistor, which is a C5206, and our adjustable voltmeter display module, our adjustable voltmeter module, this one, on the output. So these two wires, which I said they are on the input, we have to connect them straight after the capacitor. So what we need, to connect, which one is our negative to negative, positive to positive, and that's all. Yeah, in order to understand at the end, don't worry. If you are lost or you can't see what I'm doing here, don't worry. Just give me time. Just give me time. At the end, we'll try to draw the schematics so that everyone, our own schematics. Yeah, this is a BST African Electronic Surgery schematics. That's interesting. So it's very funny, guys. What we can do, I've been fixing rubbish since long ago, so I'm now get used to my madness, you know. Good. So this one is now okay. Don't worry, I'll stick everything with hot glue after. This one is to come here. Yeah, we're going somewhere. Wait a moment. It's too early to judge me here, because even myself, I'm keen to know the end product, you know. I'm keen to see the end product. So the main thing here, from the transformer, rectifier, output capacitor, we have the switching thing, and our transistor, which is in this case NPN transistor. Now let's try to focus on this side. What do we need on this side? What we can put? Just a fan? No. I think we can do something. I'm thinking of doing something this side to the small transformer here. What we can put? What about USB to charge phones? Because after this we can put let me look for what do you want here? We need a bridge rectifier. One second. Let's take one from this power supply which I destroyed. Let's take this rectifier and use it. On the 12 volts output, but we need a regulator there, because we want something like 5 volts. I'm trying to take out the rectifier. That's our rectifier, which I believe should be fine, but we can test it. Don't want to work twice. The rectifier seems to be fine. So now we need to connect our rectifier . Yeah, this is going to be long because we didn't do any research here. Maybe if I've done research, it was going to be easy, but I was just thinking all these things instantly. So some of the things I have to pause and try to look for the components. But for the major components we are done. We only left with a few things here. Capacitor. What kind of capacitor do you want here? I think if we get something like 16 volts. Let me see this one. We don't want a big capacitor here. Well, this is going straight to the USB. 10 volts. Where can I get a capacitor? 16, what about 16 volts? 16 volts, 1000 micro. You know, this board needs a lot of heat, this one. Let me look from CRTV for 25 volts, 1000. Still is fine. Still is fine. For 12 volts output, that should be okay. So that's our capacitor, which I need to connect to the rectifier. That's the capacitor. And good. And the minus. Minus from the bridge rectifier to the minus of the capacitor. Hopefully this thing will work, because I can see now on the OBS it's almost an hour. So I don't want disappointment after spending 1 hour trying to do something that I think gonna help in the thing. Okay, so now our capacitor is out. Let me look for the USBs. Where do I get to USBs? This is the panel. I don't know what kind of panel is this. Let's try to break everything, and we're left with all USBs. So what I've done, I cutted this thing. We don't need this small capacitor. We don't need it. Yeah, these are the USBs. So on the USBs, remember the pin out for the USB. We have plus and minus and some data pins. So we have to know which one is plus, which one is minus, so that we know I am trying to understand how this thing is working. These USBs which are connected in parallel mode. We have a broken track here. Because all pins on the minus should beep together and pins on the plus should beep together. Now fine. And all what we need to do is to short the data pins to plus, so that it will carry more power when we are charging the any device, any kind of phone. So I'll short the data pins to the plus. I'll short the data pins to the plus. Then we'll try to connect our thing, because we want to charge the power. We want to charge phones using this power supply. What do you think? We need to tie in wires here. I need to tie in wires. I think I'm using the wrong size of wires. So let me short all the data pins and then we'll continue together. Let's continue. So we now have our USBs. These are our USB. I cut all the data pins and connect to plus, and here we have the linear regulator 7805. So we need to finish with these small transformer things, because that's where we need. Okay, we need another wire. Because what we are going to do here, we are going to connect the USB to charge phones, and then on the fan side we shall take 12 volts soon after the rectifier straight to the fan. That's not a big problem. So all what we need to do, this one is minus is coming to the middle pin of 7805, which I believe is the minus. Yeah, I knew it. This video was going to be long. Why? Because, you know, if you are trying to build something from scratch, obviously it will take time. It's an obvious thing. Pin number 1 of 7805 is the input pin, so I'll connect it straight to the output capacitor, to the plus here. Don't worry about too many wires. Let not these wires vex you. Let these wires not confuse you in any way. So the output is here, pin number 3. Pin number 3 of our linear regulator. That's fine. Now we need the ground and only plus straight to the USB ports to supply 5 volts for charging, and I'll be done. Let's connect our USB thing, the plus and the minus. So this one is going to the plus, good. Now we need the ground. ground, ground is this one. Remember, we tested this thing already. Good. Now what is left? Why? Something just to fall down here. The supply pin after the resistor. Now our power is going on two different directions. We have this for the small transformer. What this thing is doing, just to a brief summary of what we have done, because I'm about to finish up. We have two transformers on the input, a big transformer for the main power rail, main adjustable power rail, but this is stretching. We'll see. I think up to 20 something volts. And here, what we did, small transformer, rectifier, we have filter, we have our linear regulator. In this case, we use 7805, and on the output, we have the USB ports, but we have to put in, I think it would be wiser if we put an LED on the output, because we have to see what's going on there. Let's test these LEDs, because we need an LED on the output, which indicates that everything is fine. What do you think? What do you think about my idea? So let's turn down the LED. Good. I just take random LED, and our LED will be which one is the plus? Plus to plus. Let's connect our LED in serial mode to the 5 volts power rail. Good. So that's what is on the 5 volts power rail. On the big one, big transformer, rectifier, filter, capacitor, which is 50 volts, and after that the plus is going straight to the collector of this NPN transistor, which is switching this variable resistor. In that way, we can adjust any kind of voltage that we want at the end. Simple thing. So it's good to test before I put everything with hot glue. Probably we need only heat sink for this rectifier bridge, but we'll see. We'll see. We need to make sure that our thing is working. You see the light? Let me power it off. All the lights went off, on. We have something like 12 volts on the output, and our variable resistor, this is a 30 volts power supply. You can see 31 volts. Wow, just wow. So this side seems to be fine. I'm curious about this side. Yeah, our LED is still on. Once we have to see what's going on there. Where's my phone? My phone? Oh, what's going on with my webcam? Yeah, my phone. And the phone is charging. You see? Check here. Our phone is charging at 91%. So we are pretty sure that the DC power supply is fine. The 5 volts power line is fine. Let's power off our thing. We need to do one more thing. The fan, don't worry about the fan. I know how to deal with the fan. It will be spinning all the time. And it's a big fan, you see? You can see the size of the fan. This is a very big fan. It will cool everything inside. So it's a better modification. So what is left? We need the probes. We need to connect the probes here. That's what is left here. We need 2 wires for the probes. Black and red, like usual. Black and red like usual. I need 2 wires. Let me cut down the wires. So let's connect our probes. 2 wires for the probes. And need more soldering wire. Soldering wire. Yeah, our thing seems to be working. No two main components inside. The minus will connect to the first pin of our variable resistor here. The first pin of our variable resistor, that is the minus. I think we need to make use of hot glue like serious here. Our minus is okay. Now we need the plus. The plus should be connected on the emitter of our transistor. Emitter, that's where we will put the plus term, the plus connector, and that's all. So we need to put all these things together. Let's start with this. Our cover will come. I need to see how this top cover will look like, so that we need to make use of hot glue here. Otherwise, things can go bad. So we have to make sure we stick everything with hot glue. Yeah, I'm pulling out the probes, minus and plus. What A? Let me play with hot glue. Let me stick everything with hot glue and then we'll see together. So now I've stick everything with hot glue. What is left is to solder the fan. Well, the fan is not yet soldered, and which one is the minus? Straight on the rectifier. Well, this rectifier is 12 volts DC. I think that would be a good idea if we put our fan here. Why? The minus and the plus. There are two main wires inside. And the plus. That's good. So we must have a working fan now. So we are done. All what is left is to close up this thing and see if our device is working properly. That's the most important thing. That's the most important thing here. Otherwise, we don't want this to be wasted effort. Okay. Yeah, we need some modification here because this fan can't get inside. That's all. Yeah, the fan is very big. And now it's fine. Now it's fine. So let me put all the screws. Why? Why I'm still facing challenge to close up this thing? I don't understand why. What is overlapping here? Yeah, I'm trying to close up this lid so that we'll do the final test and a little bit of theory. That's all what we need to do here. That's all what we need to do. So let's close up this thing. We need like 4 screws. Two more screws left. We're gonna get 2 more screws. Two more screws. Let me look for 2 more screws. Right, I found them. And that's all. That's our variable power supply. You know what? I just close up, but I didn't test the fan. Let's plug in our AC. AC plugged, power on. And the fan is spinning. You can hear the sound of the fan. Our fan is spinning, and here we have all the digital thing here. Maybe if we can get rid of the reflection. Now we have 13 point. Let's just test up. We have 13.6. How can I do it? Because I want you to see what I'm seeing here. Yeah, like this. So 1.9 volts. Let's raise 3 volts, 4 volts, 5, 6, 7, 8 point, 11 point, 14, 17, 20, up to 30 volts. So this is a linear power supply which is giving us maximum 30 volts. Yeah, it will be 32 point something, but on reality it's 32 volts. And here we have this LED for the 5 volts. It means all our ports, they are working. We have like 3 ports connected in parallel mode, all providing 5 volts for charging phones. And here, you know what, I think we can test. Yeah, I can hear the coolness of the fan. I can't believe we have done it. I can't believe. So let's check what we have. Some probes here. These are our probes. These 2 wires which are coming out. Let's check what voltage do we have there. Let's check the voltage. Check on the screen. Okay, plus. Check on the screen, 31 volts. And you can hear the sound of this fan. And everywhere on my tab was very cool. This is a classic. What do you think about this? So we have just made it. So on the USB, I can plug my phone. Let me put it here. On the first port, it's charging 90%. Let me come with another cable. On the second port, while this phone is not charging, I can see let me power it off. This phone is also charging. What do you think about this product? Is this not a nice product for everyone? For home use? Yeah, the fan is spinning, very cool. You can see the charging sign. And mine is charging also. You can see this charging sign on this item, and it's charging. And mine is also charging, you see. So on the phone side, our device is working fine. On the phone side, we don't have any issue. On the adjustable power supply, I think we can test. Let me adjust to 12 volts and try to power on this LED strip. And it's working. You see? Check here. Check. This is beautiful. So check. So I set it on 12 volts. It's working. What about charging cell phone batteries? We are boosting one. We want to boost batteries 5 volts. Minus, plus. So just made it. The fan, I'm proud about the fan size. Everything is being cooled up, so we can't have like any component overheating from inside. Yeah, it has indicated our phone has got this battery has got 3.84 volts and it's charging fine. To prove that, let's come with the multimeter. Let's see this. How many volts do we have on this battery? 3.84. You can see on the screen. So we are charging cell phone batteries now. You can charge anything, because this is stretching to 30 volts. So anything, cell phone batteries, all kind of batteries with the different voltages less than 30 volts. I'm happy, guys. So what we have done here, we've built our own. Let me power this thing off, because the fan is too, you know, it's already cold, and this fan is very big, and there's now fresh air on my table. So our power supply, adjustable power supply, this one is a linear one, what we have built here. This is a linear adjustable power supply, what we have built here from scratch. So let me look for a paper and a pen. So what we have done here, I turn off our switching power supply. What we have done, let's try to build our own schematics here of what is inside this thing. So that's linear power supply. So we have AC 230 AC, that's our AC. After the AC, we have what did you put there? We have like the big transformer. That's our big transformer. That's our big linear transformer, which is outputting 23 volts AC here, and in parallel to this we have a small transformer. That's the small one, which is connected together here. We have like this wire is connected here, this wire is connected here. We have two wires on the input, and on the output of the second one is outputting 12 volts AC. So after this we have the rectifier. We have put a rectifier here, AC plus minus. After the rectifier we put our capacitor. No, what am I doing wrong here? Here is plus, here is minus, and here is AC. Yes. So we have put 50 volts, 680 micro capacitor here on the plus. And where this plus is going, where our plus is going, okay, our plus is going to connect here let's put our transistor here and our variable resistor here with an arrow. This is an adjustable resistor. That's the symbol of a variable resistor. So we do have base and base emitter collector. No, it's base collector emitter here. So this transistor is switching this thing, because on this thing you have 3 pins. We have 3 pins, and the plus here is plus, here is minus on this variable resistor, and the plus is going to which pin of the transistor? Which pin of the transistor? An idea what we did there. The plus of the plus is going straight to the collector. This plus, which is coming from here, is going straight to the collector. Good. So here we have our, that's the collector, where we are getting the DC voltage from this big chopper. That's the input, and another pin, we have like 2 pins which are connected to this variable resistor. Remember what we did? We connected the 2 pins, which is base and collector. Base and collector, and the collector is connected to the plus of this thing, and the base where our base connected, and the base is connected here. Remember we have 3 pins on this variable resistor. Let's connect our base here. It's going straight where there's arrow, which is fine. And this collector, the pin, remember the pin of the emitter, sorry, the pin of the emitter from this, was this an NPN transistor? What we have used there is a C5296. I just took this transistor from CRT boards for the old TVs. Nothing special about this transistor. So our plus is connected here to the collector, and we took another plus here and connect a resistor that was a 10 kilo ohms, if I do remember. Yeah, 10 kilo ohms resistor, and is going to the what do you call that one, the display thing, adjustable voltmeter module, adjustable voltmeter module, and the minus or minus let's try to charge this thing and see what's going on here. Let's try to charge this battery. If this battery gonna charge, but I'm 100% sure the battery is going to charge. Let's charge our battery. I can see voltage is going up. Let's just wait a moment and see if this battery will gain power. Our battery is still charging. Let's just be patient because I want to see if the voltage is changing from 6.19. Remember, this battery before we put it here was 6.19. Because we have to make sure that this product is working. So yeah, this was a very long video, but hopefully you learn how you can come with the different components and build a working thing. If you know that's the catch of learning electronics. If you know how a transistor is working, if you know how a resistor is working, if you know how a rectifier, a capacitor, variable resistor is meant to work, you can do anything. You can create anything. You can create anything. So that's the catch about learning electronics. You don't need to go to any school. You don't need to waste too much of your time doing 5 years, because even if you do 5 years there, what we have done here, after 5 years, it's like you'll be starting a new program. So the best way is to start practicing. Let's see now. Let me power off the power supply. It's on. Yeah, it's now off. So now if I'm to check on this battery, 13.75. How many minutes did I put this battery? Close to 5 minutes. That's amazing. So it's charging batteries. If this thing can charge this is a 9 volts battery, 12 volts battery, sorry, but it's almost overcharged because it's reading 13.4. So this device has to be monitored. If you are to make one, make sure I won't leave the battery plugged for a long time, because bad things can happen. You know what I mean? If you are in cell phone repairs and you want to come across some incident of battery explosion, you know what I mean. So Yeah, I spent much time because I wanted you to understand how you can build your own variable power supply. Because this thing, I'm going to charge cell phone batteries, I'm going to charge cell phones, I'm going to charge anything that I want. As long as it's a lithium battery, I think we are going to do something. So that's the only way how you can learn electronics. That's the only way how you can learn electronics. You will never ever learn electronics through reading books. If you love to do like repairs, trust me, if you are someone who loves repairs, you will never ever learn electronics by only theory. You will never. So it's a combination of theory and practical. If you have books, try to replicate what you have learned on practical things. Because there are people who went to university colleges, they learn transistors, capacitors, but on the ground they can't even know this is a transistor, this is a MOSFET. Here we use a big transistor, an old transistor from those old TVs, which is fine because the transistors, they are current controlled, which they changed to this modern electronics where they are using MOSFETs, which are controlled by voltage. So that's the thing. Hopefully you understand how we manage to bring something like this. Yeah, you can plug it. It's using AC, and there's a switch. It's on. The fan is spinning. Voltage is being adjusted. You know, I'm proud of this thing. Now we have like a, yeah, I'm trying to get rid of the reflection so that you see 10.7 volts, 7, all the voltages are changing, 23. So if you are to charge something for 5 phone batteries, you just go straight on 5 volts. 5 volts. If I'm to charge a laptop battery, you go straight on 19 volts. 19.4 and 30 volts, depending with what you are to charge. So our power supply is working. So lastly, before we go, I do have a laptop here. Let me adjust my webcam. I do have a laptop here. This is a Lenovo G50. I took out the battery. There's no battery here. Plug in to our new power supply, which we made at BST African Electronics Surgery. Plug in. There's no battery there. No battery. 19 volts. Let's try to see if this power supply is strong enough to power on the laptop. So are we ready? On. Why? 1 second. And our laptop is turning on, you see? It's loading Windows. There's no battery here. No battery. So we've done it. We've done it. You can see the laptop is still on and it's loading Windows. Still on without the battery. So what can I say? Yeah, I can see it's now more than 2 hours. Speaking of the power supply, so what can we say? Like, subscribe, don't forget to turn on the notification bell. Keep practicing guys. One day we'll get there. See you on the next one. Bye.